Hey guys, here's a video to help you with the new rules that we're going to use and actually review a little bit of the original rules as well to do these proofs, these argument proofs. So let's get started. Let's review some of the basic ones from yesterday. We had our modus ponens, where you had if this, then that, this, therefore that. So that was our first one, modus ponens. We also had modus tollens, which is if this, then that. Well, not that, therefore not this. Okay, and then the last one we did was disjunctive syllogism, which was if this or that, not this, therefore that. And yesterday people were getting, there were two sort of sets of things confused, that people got confused. These two, because they both look like if-thens, which they are, but the difference is what they give you as that second premise. If they give you the if, you get the then. If they give you the negation of the then, you get the if. So that's the difference there. And then some people were mixing up these two because they sort of sound the same. This is if this, then that, but not that, right? This is if this or that, but not this. And I think people were getting a little mixed up. But the obvious thing is, you know, an if-then, you're going to use modus tollens, and or you're going to use disjunctive syllogism. Okay, so maybe with a little more practice, you'll start to get a little more of the hang of those. But here's a new one. This one's called conjunction. Conjunction is just a way to put things together, okay? So if you have P and you have Q, therefore you have P and Q, which kind of makes sense if you think about it. I'm going to the park. I'm going to read quietly. Therefore, I'm going to the park and I'm going to read quietly. Remember that example? So that's conjunction. It allows you to put things together, which you'll see will be very convenient when doing some of these other proofs. Sort of the reverse of this would be called simplification, where you have P and Q to start. My statement is actually, I am going to the park and I'm going to read quietly. Well, therefore, I'm going to the park. Similarly, I could have just said, therefore, Q, right? I mean, there's no difference between, you know, P and Q if I reverse the order. So P and Q, I could literally pick apart whichever piece I want. So I could put them together with conjunction. I could take them apart with simplification. And here are the abbreviations. I usually just use CONJ or SIMP. It's not a big deal as long as I can see, you know, it's obvious what it is and you're not mixing it up with anything. Okay, let's do an example with that. And so here are my premises. I have P, I have Q, I have if P and Q, then R, therefore R. All right, so I'm trying to prove R. So here's the only R in any of the premises. So somehow I got to get here. Well, hopefully, you know, with your familiarity now with the basic rules, you know that if you have this part, you can get that part. Well, I don't have this part yet unless I put these two together. And that's going to be your first step. I have P, I have Q, therefore I have P and Q using numbers 1 and 2 and the conjunction rule. Now I have the this, right? If this, then that. I now have this, therefore that. And that's classic modus ponens, 3 and 4. Okay? Another example. I have P and Q. I have if P then R, and I have to prove R. So same kind of idea. I'm still trying to prove R here, which means I must need P if I'm going to get R here. But right now I have P and Q together. That's not what this says. This just says that I need P. So I'm going to take the P from P and Q using simplification. So notice this, I think this is the first one where we had just one premise that you use to get it. And that makes sense because once you have P and Q, it just takes one step to pull out, you know, P, or one step to pull out Q, depending on which one you need. And now 2 and 3 is a classic modus ponens again, just like, you know, the original one. Okay, so that is simplification and conjunction. Now we have one called addition. Okay, this one's a little bit intuitive, maybe not intuitive is the right word, maybe a little more abstract. It's a little more abstract because you have this, you know, any statement you want, and then all of a sudden you can you know, connect it with an or to any other statement you want. So think of it this way. Remember when we said for our truth table for P or Q, we said all that has to happen is one of them to be true in order for the statement to be true? Well, if you already know that one of them is true, what does it matter what you put with it, right? If P is always going to be true, I could put any string of things on this side and the whole statement would still be true because P was true. So I have P, I can put P or anything, literally anything. And that's going to be the hard part, is sometimes you have to come up with what goes here to help you along in the proof. Okay, the thing to look for one of these would be a letter that seems to come out of nowhere sometimes. Okay, it doesn't always happen that way. It might be a letter that's obvious, but sometimes it just seems to come out of nowhere. That's addition, ADD. All right, here's an example of that. Perfect example of what I just said. You have P, then all of a sudden you're supposed to get a P or Q implies the R this time. Well, there's no Q's anywhere. So you know what? You add it to the P. So you have P or Q now using number 1 with addition, and because you did that, you now have the this to get the that, which is again classic modus ponens. That's how you would use addition. You use it very creatively to come up with a piece that you wouldn't normally have to help you along. Okay? Here's what I'm sure Sean's been waiting for the last 24 hours. We now have a rule to apply the not, basically. Okay? Double negation, DN. If you have not P, then you get P. It works both ways, actually. If you have P, then you could get not P. Double negation, it can work both ways. All right? So there's that one you probably knew was going to happen anyway, but now we have a name for it. Here's an example of how it would work. You have not Q. You have if not P, then not, if you have not P, then Q. And somehow we're supposed to get sort of positive P, right? Just P. Well, I have not Q, so that kind of matches. I'm okay with that. I think that's classic modus tollens, right? If this, then that, not that, therefore not this. But not this is really a not of a negation, right? We talked about that yesterday. So that's classic modus tollens right there, but I'm supposed to get P this time. So I have a not P, I can go ahead and say P because of double negation, and it's strictly for step 3. Okay, so this one's gonna be a little tricky because you have to decide, is it, you know, do you keep it as the not something, you know, or do you actually want to use the double negation? On the example we did yesterday, we actually wanted to keep it this way. Okay, otherwise you're gonna have to turn the P back into not P later on. All right, that's double negation. And then the last one for today, law of biconditional propositions, abbreviated BP, which probably sounds like the most confusing one of them all, except for the fact that this is a dead giveaway, this biconditional, because you're going to see the double arrows, okay? Or you're going to end up with the double arrows, or you're going to see the double arrows. In fact, I wrote it both ways. It's sort of the way of breaking apart the if and only if. Remember, the if and only if was the arrow going in both directions? So if you have both arrows, P to Q and Q to P, then you can put them together. If you have them together, you can pull them apart. Okay, so it's out of convenience, whichever way, you know, it makes sense in the proof, that you're going to want to make that decision. You won't really know till you see what they give you. Okay, so all this is a way of breaking apart the biconditional or putting it back together, whatever's convenient. Let's see a quick example there. I'm giving you not P, I'm giving you if P, if and only if Q, and somehow we're supposed to get not Q out of that. Okay, there's no rule right now with 1 and 2. This isn't modus tollens. I can't just get not Q out of that. It's not modus ponens for sure because those don't even match. So I'm going to have to pull this apart and do some, you know, shenanigans here. Which way do I want to pull it apart? Let's see. So let's start out with both, actually. Let's actually just pull them apart. I was going to say you can really pick whichever one you want, but it's probably better to list them separately. I think in some of the examples it might have listed them individually, but just to get the main idea. This right here means if P then Q and if Q then P. That's the definition of what the biconditional does. It's an if and only if. So I broke them apart. Now which one do I want? If I keep one with this part, I don't think I can do anything with that. There's no rule that says if P then Q, not P, therefore something. So I need this one because there is a rule where I can have a not P with a Q implies P and get something out of it. So I'm going to actually use this one. I'm going to use simplification to pull Q to P apart and now use 1 and 4. Now look at 1 and 4. If this, then that, not that, therefore not this. That is modus tollens, straight, you know, regular straight up modus tollens. Nothing fancy there. Okay, so the dead giveaway for biconditional is anytime you see double arrows, you're pretty much guaranteed you're going to use it somehow, some way. Okay, so that's kind of an easy one to spot. It's not an easy one to, you know, apply necessarily. Okay, all right, that I think should do it for the basics. The other video is actually going to be just example after example so you can practice with me as if I was here. And if you have time, you can start on the homework after that. Okay, hopefully this helps. If you have any questions, please contact me. I will be more than happy to help you along. All right, talk to you later.